Whenever you add a smart thermostat to a circuit, what you're doing is adding another appliance onto a circuit that was never designed to anticipate and feed that additional load. So let's begin with this. One of the first things you want to do is you actually want to look at your transformer, and there is a data plate on there. On that data plate, you should be able to read what is called a VA reading, or volt amperes. Now, in most HVAC situations, especially on hydronic boilers, you're going to have a 40 VA transformer. It's very common. What you want to do then is you want to take a look at what kind of zone valves you're working with and how many of them do you have. So on the left here we have a Honeywell 4-wire zone valve, and on the right here we have a Taco Powerhead zone valve. Now there's a pretty good rule of thumb that I go by that you can use with the information that we just gathered. A 40 VA transformer is typically pretty good. They handle up to 5 Honeywell zone valves, whereas the same transformer may only handle up to 3 Taco Powerheads because they use a little bit more. Now the whole point of this is to determine how much room you might actually have to add a smart thermostat without making any modifications at all. If you have 3 Honeywell zone valves and a 40 VA transformer, you still have enough room for 2 more zone valves, and typically that might mean you have enough room for 1 or 2 smart thermostats without making any modifications. If we have 3 Honeywell zone valves, our 40 VA transformer can handle a 5, but you actually want to upgrade all 3 thermostats to smart thermostats, you can just upgrade that 40 VA transformer to a 75 VA transformer, and that'll probably be enough to handle everything. Now with all that said, when you're upgrading 3, 4, 5 thermostats in the home to all smart thermostats, you're typically going to have to do a little bit more than just upgrading a transformer. Now adding a dedicated transformer doesn't take a lot, and it doesn't have to be expensive. You're going to need just a couple of things. Obviously you're going to need a transformer, and you're also going to need some kind of a relay mechanism. Now a lot of people do videos like this. You may have seen them suggest rib relays. They do work very well, but if you're doing 4 or 5 zones, you're going to need 4 or 5 relays, and that doesn't really seem to make sense to me to buy that many. Others may suggest a zoning panel board like this. This is a Taco 3-zone relay. Now this is not really dedicated power, because what you're doing is you're still powering your thermostats and your zone valves off a single transformer. The only good time this might be a good option is if you have a 4 or 5 or 6 zone relay with 2 transformers in it, so you can kind of split your system up 3 and 3 and kind of make it work that way. But in my opinion, the best route to take, the cheapest, and it works great, is a simple little relay board like this. Now this is an 8-channel relay. It only costs me 40 bucks. And if you don't have 8 zones, you don't need to go to the extent of buying an 8-channel relay. You can get 4 or 6, whatever you might need. And finally, we're going to add a little 3-amp fuse, because our thermostats are delicate, they are expensive, and we don't want to fry them. So this little sucker is going to save us from silly little mistakes. So grand total here, I think I spent maybe 60 bucks, and if you don't need an 8-channel relay, you can go a little cheaper than that still. So before we even take our smart thermostats out of the boxes, we're going to do all our wiring first, and then we're going to use our battery powered thermostats to test the whole circuit so that we don't have to use our new thermostats on an untested circuit. Makes sense, right? All right, so as you see here, I have a 1900 box. I have my wire ran down to the box my original transformer is connected to. We have black, white, and a ground wire. Now when you're using a metal box like this, you want to ground them. So I have a ground wire here with a screw down to the box, and we're just going to connect black to black, white to white, and all our grounds together in our power source box here. And then we're just going to connect the ground to the box and our black and white to our power coming in. So here's our power wiring all completed. Very simple and straightforward. Black, black, white, white. Grounds together, both ends. Now we can go ahead and we can close these boxes back up. Now I went ahead and I labeled each transformer for what it's actually going to be used for, so that anybody else working on this can be very clear about what's going on here. So I labeled this transformer Tstats and this one zone valves. So for our first step here, what I did was I took a red thermostat wire, hooked it up to the load terminal on our new transformer, and I added a little stake on here for our fuse that we can plug right in. Now they do have fuse holders you could buy with wires already connected to them, but this works just as well. And what we're going to do now is we're going to take another red wire off of this fuse, and that will eventually go on to power our thermostats. Now the first thing we want to do is we want to go to our original transformer and trace the wire off of that 24-volt load terminal and follow it up, and we see it comes right here. Now we should see other red wires connected to it. Now these are the red wires that go up to each R terminal for all of our thermostats. So this is our power source from our thermostats right now. What we're going to do is we're going to disconnect those. So the red wire coming from our transformer here, we're just going to put that aside for now. And we're going to take all the red wires going up to our thermostats, and we're going to hook that up to the red wire coming off of our fuse on our new transformer. All right, so here we can see our 24 volts coming off our new transformer, going through our fuse, and then it is connecting to all the red wires that go up to the R terminals on our thermostats. So here we are on our thermostats. We have our red wire coming in, and it is connected to the R terminal, maybe connected to RH on your thermostat, but whatever the case may be, that is our now power coming in from our new transformer. Now what you want to do is you want to look at that W terminal. You want to make sure there is a white wire coming off of that, just to confirm. We're going to leave that there for now, and we're going to find the other end of this wire, which should be near the zone valves. So here we are in our zone valves, and what we're looking for are those white wires coming back from the W terminals on our thermostats. Now you want to be careful not to go strictly by color, because people do weird things when they wire stuff up. We know the wire coming off our W terminals is definitely white, right? So when you have a Takeo power head like this, that white wire is going to connect to that top terminal, that number 1. So this white wire here, that is the wire coming from our zone 2 thermostat. So we're going to go ahead and we're going to disconnect that from the power head. Now on a Honeywell zone valve, that white wire is going to connect to one of the yellow wires going into your motor. Now this is where you want to be careful about, depending solely on wire colors. Again, we know the white wire coming from our zone 1 thermostat is a white wire, but as you can see here, I have 2 yellow wires, and they're both going to white wires. So which one is the one from our thermostat? In order to be sure, what you want to do is you want to trace that white wire back to where it goes. So this one here, for example, I have a yellow wire coming to a white wire, but it goes to the thermostat wire. It actually goes back to the transformer. So I know this is a common connecting back to the transformer. And the other yellow wire with the white wire, that is the white wire coming from my W terminal, my thermostat. So it's important not to get them confused. If you're not sure, trace them all the way out to see where they go. So we're going to go ahead and we're going to disconnect the white wire from the W terminal on our zone 1 thermostat, like that. So here's where we are so far. We have power leaving our new transformer. It is going through our fuse. It's going up to each of the R terminals on our thermostats. When our thermostats call for heat, it's going to send those signals onto the W terminal, which we know is a white wire that comes down to our zone valves, which we just disconnected. So now we got to take these white wires and we're going to start connecting them to our relay. Now every relay works off of the same fundamental principle. It receives a signal from one circuit and then activates a switch that's on a completely different circuit. So along the top here on this relay, we have all these green terminals here. The 2 white ones are common, and each one of these green terminals activates a corresponding switch on the other side of the relay. So what we're going to do is we're going to take the white wire from our zone 1 thermostat and we're going to hook it up to this first terminal here. Now it's very important to keep track of what you're doing here, because eventually we're going to hook zone valves up to the other side of this relay, and we want to make sure our thermostats and our zone valves match up. We don't want zone 1 thermostat to be turning on to zone 3 zone valve, for example. So very important, keep track of what you're doing. So what I have now is the white wire coming from our zone 1 thermostat. Let's say that's our living room. All right, it's coming down to the white wire near our zone valve here, and this white wire is the one I took off my Honeywell. So the Honeywell is our living room zone valve. So I hooked that up to the number 1 terminal here on our relay. So Again, make sure you keep track of this, because later on when we hook up this zone valve, we want to make sure it's hooked up to the right relay. So that white wire on the one terminal is the relay on the one terminal that we will hook up our Honeywell zone valve to eventually. Now I'm going to take the wire from our zone 2 thermostat, and I'm going to hook that up to the number 2 terminal here on our relay. So we have our zone 1 thermostat, which is our living room, coming down the white wire going to our terminal number 1 on our relay module. We have our zone 2 thermostat coming down white wire that we hooked up to the number 2 relay terminal. And so relay switch number 1 is our living room, and relay switch number 2 is our zone 2. Let's call that the master bedroom. So when each one of our thermostats call for heat, it's going to power each one of these individual relays that we've assigned to it. So all we need to do now is actually complete this full circuit, because the power can't just stop right here. We have to connect a common from the relay back to the transformer. So what I'm going to do is I'm going to hook up a blue wire to this common. I only need one of them because the commons connect to all these terminals here. So I'm just going to take one blue wire off of the common on this, and I'm not going to connect it to the relay just yet. So here's my blue wire I hooked up to the common terminal on my relay here. And the reason why I didn't hook this up to the transformer yet is because we're installing smart thermostats that need a common wire. So what I'm going to do now is I'm going to take the extra wire I have on each one of my thermostat wires going up to my thermostats, and I'm going to go ahead and make the connection on common to this blue wire here connected to our relay board. So the extra wire I'm using as a common on all my smart thermostats is blue. So I took all the blue wires from the thermostat wires coming down from my thermostats. I connected them to the blue wire I hooked up to the common on my relay, and I spliced them all together and ran another blue wire back to the common on my transformer. What I'm going to do now as a checkpoint, like halfway through my wiring, is I'm going to open up one of my thermostats, and I'm actually going to make the connection of that blue wire to a common terminal. And the reason why I'm doing this is what I'm going to eventually do is I'm going to take the batteries out of this thermostat, I'm going to hook it back up with the common connected, and then I'm going to turn the power on, see if this thermostat actually powers up without the batteries in it. And that will tell me my circuit is complete and everything's good to go. So my blue wire is now connected to the common on my zone 1 living room thermostat. I'm going to go ahead and close this up, and I took the batteries out of the thermostat. You can see it's completely dead. I'm going to go ahead and put the faceplate back on, and let's go ahead and turn our power on, and let's see if our thermostat turns on. And there you go. As you can see, our thermostat's powered up without batteries in it, and that means everything is looking good. And eventually, when we're ready, we can go ahead and hook up our smart thermostat to this. But for now, let's start working on the other side of the relay, which is wiring in all our zone valves. So as you can see, I tidied up all the wiring we did so far. It's nice and neat. It gives us a little clearer view of where we are and what we're doing now. So right now at this point, all you should have is that initial red wire we disconnected from our original transformer still sitting there aside. We have a yellow wire that originally powered the motor on our zone valve, not connected to anything, and on our Takeo power head we don't have any wires hooked up to that number 1 terminal. So what we need to do now is we need to bring power in from our what is now our zone valve dedicated transformer, and we need to bring it into each one of these relay switches here. Now what we're doing here is we're bringing a power source into the switch so that when the switch closes on a call for heat, that switch can take that power, pass it on, and activate the corresponding zone valve hooked up to it. So what we're going to do is we're going to take this red wire coming from the 24-volt load terminal on our zone valve, and we're going to connect the red wires here to each one of the relays for each one of our thermostats and our zone valves. So as you can see here, here's our red wire coming from the 24-volt load terminal on our transformer for our zone valves. I spliced 2 red wires onto it because we're changing out 2 thermostats here, and I put one on the channel 1 relay and another red wire on the channel 2 relay. Now, as we said earlier, that number 1 channel is for our living room, so that is our Honeywell zone valve. So what we're going to do now is we're going to hook up the wire from that channel to relay's normally open position of the switch and hook it up to the yellow wire that operates our zone valve. Now the reason why we're going normally open is because this switch always remains in the open state when there's no power to the relay or on the system at all. And that's exactly what we want. We want our zone valve to remain closed until we decide to power it with a signal and a call for heat on that zone. So this normally open is always where we're going to go whenever we're doing this. So what I'm going to do now is I'm going to take a wire. You can use any color you want. I'm going to use yellow because the wire to our zone valve is yellow, and I'm going to go from the normally open switch straight into the zone valve motor. Alright, so here's my yellow wire hooked up to the normally open portion of the relay switch, going straight into my zone valve motor. Now, the great thing here is our common is already hooked up from we never touched it, so we're completely done with that zone valve now. So all we have to do now is run a wire from the normally open switch on our second channel here, which is our master bedroom, and run that to the #1 terminal on our Taco power head, which is the zone valve for the bedroom. Again, you can use any color you want. So here we are, it's all wired up. I decided to use a black wire from the normally open on that channel 2 of the relay for our master bedroom to the #1 terminal on our Taco power head, which is for the master bedroom. So we're done. Basically what we can do now is go ahead and test everything, make sure the boiler fires up and everything works fine. And once that is confirmed, we can then go ahead and start installing our smart thermostats. All right, so I have the power on, my thermostats are working. What I'm going to do now is I'm going to go one at a time just to test everything out. So I'm going to go off my zone 1 thermostat. I'm going to make sure it's in heating mode and bring the temperature up to activate a call for heat. So you can see our thermostat's calling for heat. It is now sending 24 volts to the #1 terminal. That has activated our relay, and now the power can travel through the switch, activate our Honeywell zone valve. Our end switch is pulled in, and as you can see, we have the light on here and the boiler's running just fine. So we're going to go ahead and we're going to bring the temperature setting back down below room temperature so it stops calling for heat. Okay, so our thermostat stopped calling for heat, our relay switched reopened, our zone valve depowered, and our boiler shut down. So now we're going to go ahead and we're going to do the same thing with zone 2 thermostat for our master bedroom. We're going to bring the temperature setting up above room temperature, and we're going to go ahead and see if everything works just fine. Now you can see our #2 relay is lit up. That means our Taco power head is starting to heat up now. Now this takes a minute, so I'm going to edit out the time delay. Okay, so you see our light turned on. That was actually like almost a 1.5 to 2 minute time delay, because these power heads, when they're cold, they take a little while to heat up and activate that end switch. So now let's go ahead and bring the temperature setting back down to eliminate our call for heat, and everything should shut off. So our relay deactivated, our boiler is now shut down, and everything's working great. So now we're ready to actually start installing our smart thermostats. So I'm going to be installing 2 types of thermostats today. I'm going to do an Ecobee 3 Lite, and over here I have a Honeywell RTH9 thermostat. So what we're going to do is I'm going to make sure it powers off on the system. I'm going to go ahead and I'm going to install the bases, and we'll go ahead and connect the wiring, and I'll show you how to do that. Okay, so here are my bases mounted. I have it wired up. Now there's some notable small differences between a smart thermostat and a regular battery operated one. On smart thermostats like Nests and Ecobees and things, they typically get charged off of the RC terminal. So even though we're hooking up a boiler here, we're not hooking up any air conditioning at all to this. We still have to go to the RC terminal. Now a lot of these thermostats, they have internal jumpers in them, and because they're smart, they know when to use that jumper and when not to. So when we turn this thermostat on and we program all the settings in it to let it know like what kind of system we have, it will know we're only running a boiler. It will use the internal jumper to take power from RC and run it over to RH. If you just hook straight up to RH, your thermostat's not going to power up. So I got the red going to RC, our blue is our common going to C, and our heating wire, which is white, is going to W1. Now on this Honeywell thermostat over here, this one actually has a physical jumper in it. So you can see that little blue jumper there. Unless you're powering 2 different systems on the same thermostat, like a separate heating and cooling system, you can leave that jumper in. So on this particular thermostat, there is an R and an RC. We just hook our red wire up to the R, blue to common, white to W, and we're all ready to go. All right, so here are our thermostats all hooked up, powered up. Everything seems to be working okay. I went ahead and went through the startup settings. I registered online and I connected Wi-Fi, downloaded the apps on my phone. So now we're going to just test them on the phone, see if the Wi-Fi signal goes through and see if everything works just fine. So I'm connected to the Honeywell stat. That is our master bedroom. So I'm going to go ahead and bring the set point up. And we'll see if it changes on the thermostat, and it did. Thermostat is now calling for heat. My module has lit up and my zone valve is now activating. So let's go ahead and go over to the Ecobee app and try the same thing. So here I am on the Ecobee app. I'm going to take the set point, bring it up above room, bring it all the way up to 75, and we'll see if it, there we go, it activated. Now both thermostats, the weather app is working. It's telling me what the outdoor temperature is. The Honeywell is giving me indoor and outdoor humidity level. Everything's working fine. And that's it. You now have smart thermostats with dedicated power, full functionality with no power issues. I'm Jersey Mike. Thanks for watching.